go ahead and take a picture of this, or you can insert it. I believe it is on page 1124 in your book, if you want a screenshot from your book. If it's not 1124, it's really close to that.
It is 1124.
Yes, 1124. Okay, and then I'll talk about what's all going on here. The end of the day, I'm trying to tell you what the log button is for and what the common logarithm is. So go ahead and get that situated in your notes, and then I'll explain what it all is. Okay, so the common logarithm is just a logarithm of base 10. We typically don't write it. We don't write the base 10 because we live in a base 10 world. So when you see the log without a base, it is understood that it means log base 10. So the log button on your calculator means log base 10. And see here how it's written without the base? That means base 10. Wow. To be perfectly honest, we just don't write it.
Why not?
Because our entire number system is base 10. And so it's almost kind of redundant. It's not necessary, and we use it most of the time. Okay? And so when it says here it's usually written without the subscript, the key thing here is when you see it, you have to understand that the base is 10 like this.
What if it's not 10?
Well, then they'll write it.
Oh, how do you do it in a calculator?
I'm going to talk about that here in a few slides. Okay? So, when we try to find logs using our calculator, we just hit the log button, and then you type the number that you're trying to find, and it will give you the value. Okay, so for example, here are some problems. So go ahead and just type those in. Hit the log button and then hit 7. And here's the thing I want to caution you on. Get in the habit of closing the parenthesis. If you have a calculator that automatically puts the left parenthesis there, so like for example, in all likelihood when you type this into your calculator, it automatically puts the left-hand parenthesis, and then you type 7, get in the habit of closing it. Okay, and the reason that I want you to get in the habit of closing it is because we're going to start doing some things with division. And if you don't close it, it's going to try to divide it all in here first instead of doing them separately. Okay, so get in that habit of putting the right parenthesis and closing whatever it is that you've typed in. So here's what I want you to round to. Okay, so you're going to write these, you're going to type both of these in your calculator. In logarithms, we round things to 4 decimal places, the 10,000th place, if it needs to be rounded. Sometimes it'll come out even. Most of the time it will not. So you should have 4 decimal places for both of these answers. Go ahead and do those now. Go. Let's understand. First of all, you should have gotten both of these. Raise your hand if you got both of those. Okay, let's understand what this means. This is, again, logarithms are powers. So 10 to the this power is 7. Okay? 10 to this power is 0.5. All right? If you were going to try to figure out 10 to what power equals 7 and evaluate it the way we did on the test, you would spend a long time trying to guess and check until you got the right thing. Same with this one, okay? So the calculator does it for us. Back in my day, we had these logarithm tables that we had to look stuff up on. These giant tables in the backs of our paper books where we'd have to find it, okay? Fortunately, you don't have to do that anymore, okay? Now, here's what this is really good for most of the time. All right, the equations that we solved so far, we've done exponential equations. That's what we did in 7.2. Okay, and when the variable was in the power, what we were able to do in all the equations that we worked on is change the base so that they were the same. And anytime we changed the base so that they were the same, we'd set the powers equal to each other and solve. Most of our equations that are exponential equations don't work out that nice. And so we need logarithms in order to do that. So for example, here's the kind of problem I'm talking about. 3 to the x equals 15. Right? I can't rewrite 15 as 3 to some power and then set it equal to x. You know, there are no factors in 15 that are even perfect squares or perfect cubes or anything. It's 1, 3, 5, and 15. That's it. None of those are perfect anything. So what we use logarithms for is to get this x out of the power. And if you remember your power properties from yesterday, If this just had a log in front of it, I could do what with the x?
Move it to the outside.
Move it to the front. So that's what we're going to do. Our strategy is going to be take the log of both sides, which you can do. And by taking the log of both sides, that power slides down in front and it becomes a regular number. So yeah, using the power property, I can just bring that x down. So how do I get the x by itself down? I mean, what does this mean right here? X log 3. What does this really mean?
Power. It's
What?
why.
What times 3 equals 15?
What to the
3 to
power?
the x power.
No.
How many times?
This
is
means,
three?
no, settle. This means x times log of 3. When they sit next to each other, they're being multiplied together. So that power then comes down and is multiplied by log 3. So if I need to get x by itself, I need to get rid of this log 3.
Divide.
So yeah, I'm going to divide both sides. Log 3.
X equals log 5.
Definitely does not.
Just kidding.
Bless you. Alright, go ahead and type that in your calculator and see what you get. This is the type of problem where I was saying you got to be very careful when you enter this in the calculator, especially if it already gives you a left parenthesis. You need to make sure you close the parenthesis around the 15. If you divide before closing the parenthesis here, it's going to take the log of 15 divided by this all inside the parentheses, and you'll probably get a different answer. So make sure, if your calculator is one that automatically gives you the left parenthesis, that you close it. Now some of you will be able to actually type this in as a fraction, which is fine, and some of you won't. Either way, you should get the same answer. Okay, this is not log of 15 divided by 3. The logs don't cancel. All right, this is one number divided by another number. What you should have gotten is 2.4650. How many had that? Okay, so let's understand what that means. Let's go back to our original problem. 3 to the x equals 15. That means 3 to this power is 15. We know 3 to the second is 9. We know 3 to the third is 27. And since 15 is in between 9 and 27, we would also expect this value to be between 2 and 3. So you can sort of go into the problem at the beginning with an idea of where your answer should be. Since we know 3 to the second is 9, which is less than this, and 3 to the third is 27, which is greater, it should be in between 2 and 3, which it is. Okay? Questions about that? Let's do another one. You do this one now. Go. So, take the log both sides. Alright, the x comes down. Divide both sides by log 6, 2.0860. How many got that? Okay, we're going to come back to this problem here in a minute because after I show you what I'm about to show you, there's actually a different way that you can do this problem. And I'm going to leave it up to you which way you do it. Okay. So before we get there, let's go to this. And I believe this is on page 1126, I think. So go ahead and either take a picture of that or screenshot it and situate it in your notes, and then we'll get back to it and I'll tell you what this is all about. All right, 1128, sorry. I knew it was somewhere near there. 1128. All right, so the question came up earlier. If my calculator if the log button only means base 10, how can I input something that isn't base 10 into my calculator? And the answer is just like this. Okay? If the base is something other than 10, we can actually use common logs to rewrite it and put the numbers in a fraction using common logs. Now on page 1128, they have the little 10s here. I erase them because we don't write the 10s. We don't need to write the 10s. Okay? So this is log 11 over log 3. So the regular number goes on top, the base goes on the bottom as a log, and you divide the out, and you'll get your answer, just like we did some of those other problems just a second ago. Okay? Now, the types of problems you're going to see and the directions you're going to see look like this. Okay, and that's a little 3. The problem where I had brought this in from had the 3 even smaller, so I had to put it on top of it. So there's two pieces here. Writing log base 3 of 20 in common logs, and then rounding to the nearest 10,000ths. That's 4 places. So our first move is to rewrite it so it looks something like this. So go ahead and do that, and then you can type it in and see what you get. Now, so here's what you should have got. Log of 20 over log 3. How many had that?
It's just you
Okay.
forgot to erase the tens.
Oh, I did, you're right. Oh, well, they're back. And then you just put that in your calculator. 2.7628, how many had that? So there's two parts there, okay? Again, writing it in terms of common logs, this is changing the base, so that now the base is 10. Okay, and then just entering that in your calculator. Question?
So when you just see that, you just put the one that's farther right on the top and then.
You put the normal size number on top and the base on the bottom.
Alright.
Okay, now I want to look at that second problem that we looked at here, again, specifically knowing how to change base now. So let's look at this problem. Before today, you maybe would have said, okay, this problem would have appeared in a situation where it said change to logarithmic form. Okay, if I wanted to change this to logarithmic form, what would it be?
Log x.
Base 6.
Four, 2 equals x.
Okay, so that's logarithmic form. Now, because I taught you how to change the base, in reality I could do this now using my calculator. Because this log base 6 of 42 can be written as log of 42, common log, over log of 6, and that equals x. Which we did that. Common log means log base 10, we just don't write the base. Okay? And we did this already, and that was the work that we ended up getting, right? In order to solve this problem, we had to do log 42 over log 6. So, you have options. I showed you take the log of both sides, and we got to this. You could also, when possible, put it in logarithmic form and use change of base formula to solve it too. You end up getting the same answer, it's the same problem. I'm showing you there's two different ways to go about it if you want to do that. And I'm telling you, you have permission to use either one, unless the directions tell you differently. Okay? Does that make sense? All right. Any questions about anything else?